Copy. I'm going to copy that, and I'm going to put this in. Now, here's what's happening. This is kind of, you guys are at a good spot with hypothesis testing because very, very often we like to compare two groups, two independent populations, right? Like if I said to you, who's more likely to smoke, men or who? Or women. So we're looking at two independent populations. So I'm going to do something like this here, okay? Population 1 versus population 2. Okay, so you got population 1 versus population 2. Okay, so let's ask the lady. Who's better, men or women? You guys know what I'm saying? We're going to compare two independent groups. Very often we want to compare who? Men versus who? Women. Very often. Who's more likely to smoke, men or women? I don't know. We can test this. We can test it with the hypothesis test. Who's more likely to drink, men or who? Women. We can test it. How about this? Boys versus who? What? Girls. Okay, you can even compare different ethnicities. You can say white versus non-white. Okay. All right, you guys okay with that? All of those, ladies and gentlemen, is what we're talking about. So we're going to like to compare different populations. Now, if you're going to talk about a proportion, what's a proportion again? You guys know what I'm saying? We're going to compare two proportions. Just because it starts with the letter P doesn't mean it's the same. This is a proportion from population 1, and this is a proportion from population what? 2. Sample 1, sample 2. Of course, you got to take samples if you're going to do this. So we're going to do a hypothesis testing comparing two independent proportions now, not one. So when you go and you read this, of course, you always want to start with the what? The language, okay? We're going to start with language here. So you have here the proportions which is P1 and P2, right? What's a proportion? Do you guys remember? It's a probability. It's a percent. So when they say those proportions are the same, what do you think they mean, right? Two proportions, the proportions. They mean what you guys see here. P1 equals what? P2. Okay, isn't that what it means to be the same? You are equal. All right. What about this one? The proportions are what? They're not the same. P1 not equal to what? P2. So you can also see the language that says that the proportions are what? Are different. So the symbols associated for the language not the same or not the same, the proportions are different. That's not equal. Okay, you guys okay with that? It's not equal. Over here, saying they are the same means they're equal. Does that make sense? Here, proportions are, and this is going to be for some people, this is the hardest one. If they say the proportions are not different, what does it mean if you say to somebody, hey, I'm not different? You're saying they are the what? The same, they're equal, yes. Not being different means you are the same. All right, you guys okay with that? Here we go. P1 is what? More likely than P2. P1 versus P2. More likely means a higher what? Probability, because proportions are percents or probabilities. So if I said, who's more likely to smoke, men or women? See the language? That means a greater than probability. Who's more likely to own an Xbox, men or women? What do you think, ladies? Would you rather own an Xbox or would you rather own a PS5? Don't know. What about less likely? P1 versus P2. Where's the story? Less likely. P1 versus P2. This is what? No more than, which is what? Less than or equal. And here, P1 versus P2, at least, which is, and this is, there was a typo on this one, just so you guys know, this would be greater than or equal. Okay? So I want you guys to chew on the language here, because that is where it starts. And this is actually going to be a highly useful topic for you guys, because this is really what's under the hood for a lot of different studies. We want to compare probabilities, which are percents. They're called proportions, generally speaking, for two different groups. Who's smarter, men or women? You might say, what do you mean? Now, I know it sounds horrible to say. I know it sounds, Mr. Judge, can you please tone it down? Well, if you're thinking like a scientist, scientists want to know and answer some of these questions. Whether you're a scientist or a pseudoscientist, you know, maybe you measure the IQ scores of men and women. You guys see what I'm saying? You remember that IQ stuff that I had you guys do for extra credit, right? What if we gathered data and said, you know what, I'm going to gather data and I'm going to separate those IQ scores by men versus women, and we can now determine who's what? Who's smarter if you consider IQ score smart, right? That's a legitimate thing to do, scientifically speaking. Sounds horrible, but that's legitimate. You guys see what I'm saying? And there's probably studies on that, so it's interesting. So I don't know. I think this is an exciting time. So let me do something here, and again, we're going to compare. Of course, this is all based on you taking samples, right? Okay, here we go. The hypothesis testing procedure is the same. In fact, let me mention this to you guys. We'll go through it. I have notes on it. In the past, yes, you'd use test statistics. Okay. Yes, we'd use the Z distribution. Okay. And we could even try something like this one here, but I might make up another one. Let me see. Do you guys care about smoking? I don't know. I'm going to do another example. I'm going to make it up. How about this? Let's try one, okay? This is a hypothesis test. Let's say hypothesis testing about two proportions. Now let's think about this. Compared to proportions, men or women, what do you think? What should we say? Should we do something? Should we do IQ scores? Yes, let's do that one. How about this? I did that example with the morning class. Here we go. What do we say? Oh, actually, I didn't do that. That was a different parameter. So let's not do IQ scores. We have to do something different. We might say, how about this? Oh, how about this? The proportion of female students who pass statistics is the same as the proportion of male students as claimed by Snodgrass. And I'll say this, a sample of 120 what? Female students reveal at 98 passed statistics. And a sample of 150 male students. Revealed that 122 passed. Use the 5% level of significance to test this claim. Okay, you guys okay with that? You want to write that down and see what's going on? All right, here we go, ladies and gentlemen. Here's the deal. Let's read this, okay? You guys remember they're saying what now? The proportion of what group? Female college students who pass statistics. What's the phrase here? Is the same as. The what? Proportion of who? Male college students. As what? As claimed by who? Snodgrass. P1 versus P2, okay? What does it mean to be the same? Equal. Here we go. You guys see here? Where does this go? Is this a null or is this an alternate hypothesis? Anybody want to tell me? Is that a null or an alternate?
No.
How do you know it's a null?
It's equal.
Good job. That's how you know. That's right. That's, you guys see what I'm saying? Now, what's the opposite of equal?
Not equal.
Good job. And now, ladies and gentlemen, once I see that, you know what I say to myself? This is going to be a what? A two-tailed test. Okay, you always look at the what? You always look at the alternate hypothesis. If it's not equal, it's a two-tailed test. Easy peasy lemon squeezy?
C.
Now, we're going to use the modern method. Right? Remember we talked about the modern method. You say, what do you mean the modern method? Well, let's take a look. What you want to do now is read the sample information. It says a sample of what? 120 what? Female college students reveal, what do they reveal? 98 past statistics. So that's the first group. Sample 1, N1, and X1. Why am I saying N and X? Did you see the word mean anywhere or standard deviation anywhere? No. Why not? Because this is about a proportion. Okay, you guys remember that? Percent, probability. Now, N and X. 120 and 98. Sample 2. You're going to have N2 and you're going to have what? X2. Okay? So when you read this, this is for the next group. What does it say? It says a sample of what? 150 male college students revealed that what? 122 passed. So this is N and this is X. So this is going to be 150 and 122. And then you're going to use the what? 5% level of significance to test this claim. Now, alpha is 5%, and that's going to be 0.05. So you might say, Mr. Judge, how are we going to do this? Well, you know what I'm going to do? We're going to use the modern method. But in the TI, what do you guys have now that's new? You're going to use now what in the TI? Stat what? Test. To proportion what? Z-test. Okay, let me say this again. Stat test to proportion what? Z-test. So stat test to proportion Z-test. I would write that down. To proportion what? Z-test. Okay, ladies and gentlemen, here's the deal. You guys ready? So let's do this here. Are you guys ready in the TI? Say, wake up, TI. We're going to do some work here. Okay, we go to what? Stat test. Which one are we looking for now? To proportion what? A Z-test. So put X1 there. What is X1? 98. What is N1? 120. Put X2. What is that? 122. Put N2. 150. What do you guys have here? Is this not equal? Is that a two-tailed test? How do we know it's a two-tailed test? Oh, we wrote that down. Not equal for the alternate hypothesis. Okay. There we go. hit calculate. Ladies and gentlemen, here you go. What do you guys get here? What is this? What does this mean? What are we looking for by the modern method? Remember the modern method, the third row, the p-value is point what? 944. Okay, let's talk about this again. That's what we need to find, the p-value. Okay, p-value. .944. So what you're going to see here for the p-value is p less than alpha. If p is less than alpha, and this is why you have to know the level of significance, because that p-value is the probability that the null hypothesis is valid. This is the probability H naught is what? Valid. The threshold is 5%. Remember, anything smaller than 5% is not likely. Is that true? So we're going to have to check, is 0.944 smaller than the 5% level of significance, okay?
Wait, is that, did it say probability H null is valid?
Yeah, that's the definition of the p-value. That's what you're looking for. But is the p-value smaller than alpha? Say what? Say no. Is 94.4% smaller than 5%? The answer is what? No.
Interesting.
So the answer is no. You know what you say? If the p-value, well, here's what the real saying is. This means here, this is what you guys want to remember here, right? Here's what I'm going to give you guys this fact here. This is what the basis of a lot of what you're going to do here. If p is less than alpha, then what do we say? Do you guys remember? Then the p, if they say this means that the p-value is low. If your p-value is low, what do we say? We said it last time. Anybody remember? Then the null has to what? Go. If the p-value is low, then the null has to go. Now the problem is here, the p-value is not low. So if you do not have that situation, like this situation now, if this is not happening, then you know what we do? Then you what? Then you keep the null. So what do we do? What's our conclusion? This is the p-value method, ladies and gentlemen. This is that modern method we're talking about. P-value or modern method. You keep the null. So if you're keeping the null, hug your null, and you're getting rid of the what? Alternate. What's your conclusion, ladies and gentlemen? What does that mean? What's the conclusion? What does it say? The sample what? Supports the claim. Why does the sample support the claim? Because what are you doing with the claim? You're hugging it. So what this test is saying that the proportions are in fact what? Equal. Okay, that means the proportions are equal. Easy peasy, lemon what? Squeezy. Easy peasy, lemon squeezy. Easy peasy, lemon what? Squeezy. Lemon squeezy. Okay, so ladies and gentlemen, here's the deal. So the men and women are passing at the same rate. That's what it means. Okay? Same proportion. Proportions are equal. Good. Let's give you guys another example here, okay? And all you have to remember is when you compare two what? Proportions. In the TI, it's two proportion z-test. Okay, let's give you guys another example. Here's what we're going to say. If, how about this? The proportion of female college students who drink coffee every day is not the same as the proportion of male what? College students, as claimed by who? Snodgrass. A sample of 200 what? Female college students reveal that 120 drink coffee every day. And a sample of 180 male college students reveal that 95 drink coffee every day. Use the 1%. Well, let's do 5 again. 5% level of significance to, I'm sorry, let me change it again. 10%. I know you haven't written everything down. To test this claim. This is the modern method. We're going to use the p-value method. Proportion of who? Female college students who drink coffee every day is what? Is not the same as what? The proportion of what? Male college students as claimed by who? Snodgrass. P1 and P2. What about is not the same? What do you guys know? What do we do with that? Which inequality is that if we say is not the same? Anybody know? What is that? Is not the same. What does that mean? Uh-oh. What does this not the same mean? Not equal? All right, so here we go. P1 is not equal to P2, and that is your what again? Isn't that the claim? Where does that go? Is that a null or is that an alternate? No alternate, no alternate, no alternate. Where do you guys think that goes? Why is that an alternate hypothesis? Not equal. Now, let's read the rest. What does the rest say? It says what? A sample of what? 200 female. That's the first group. College students reveal. What do they reveal? That what? 120 drink coffee. And a sample of what? 180 reveal that 95. A sample of 180 what min? So you got the two of them, right? So read the information and what? Write it down, okay? Isn't the first group was it the first group the females? Yeah. Females versus males. Female here, and then what? Male here. and an X. So 200 and what? 120. Sample of 180 Mayo revealed that what? 95. So this is going to be 180 and 95. Is that right? You guys okay with that? You agree with that? Those statements? As you read that, did you guys write it down? What's your level of significance? 10%. So you're going to have alpha is 10%. .10. There's your alpha. What do you guys use in the calculator? It's 2 what? What is it? What is it that we use? 2 proportion what? A z-test. Isn't that what I have in that worksheet? Oh. In the notes, the $1 million notes, ladies and gentlemen. 2 proportion what? Z-test. Let me find out where it is. Where are you at here? Okay. All right. You guys okay with that? We're ready. What do you think? Let's get out the TI. We're going to use the modern method, so we need the p-value. Okay? So let's get that. Stat test. 2 proportion z-test. So x1 will be what? 120. Okay. N1 is 200. X2 is going to be what? 95. N2 is 180. You put not equal, okay? Not equal and hit what? Calculate. What's your P going to be here? What's that P value? Do you guys know? The P value is what? Go to the nearest thousands. What is your P value? Is that 0.156? Here's your p-value. Is p less than alpha? Here's your p-value. Alpha is what? 10%. .156 is less than what? 10%. Is that valid? Yay or nay? Nope. Okay, so your p-value is not smaller than the level of significance. What does that mean? Is the p-value low? No. What happens when what you're saying is 15.6% the p-value smaller than 10%? No, it is not. So what does that mean? You keep the what? The null. Isn't that the modern method we wrote down here? Keep the null. So what's your null? Your null is right here. Let's keep it. Okay, so we're going to keep the null. And if we keep the null, what does it mean about the alternate? The alternate's gone. Now tell me about the claim, because we have to determine what this means. What does this mean, ladies and gentlemen? Your conclusion is always one of two things. Either the sample supports the claim or the sample does not support the claim. So what is it going to be? The sample what? Does not. Good. How come the sample does not support the claim? These proportions are the same. So what this is saying to you, that the proportion of females who drink coffee is the same as the proportion of what? Men. So, you know, we do care about these things. Don't we want to know how men and women are the same and how they're different? Anybody know what I'm talking about? Do you want to know these things? How are we the same? How are we different? How about this? Who's more likely to believe in UFOs, men or women? Or let's change the subject. What if I say, let's compare two different groups? Let's let the groups be, right? Let me draw a picture here. How about people who live where? Mountain folk versus who? Desert folk. Okay, so here's going to be our hypothesis. Let's write this down. We're going to say the proportion of mountain folk who believe in UFOs is different than the proportion of desert folk as claimed by what? Snodgrass. Okay, and then I'm going to do something a little bit different when I describe your sample. I'm not going to use all the words. Sample 1. They're going to say the sample size here is going to be 500, okay? And in this case here, who are we talking about? Mountain folk. Okay, the mountain folk, believe in UFOs. Let's say this is 118. Sample 2. You got 700 here. And then that's 288. Use the 5% level of significance to what? Test this what? Claim. Okay, so we're going to compare now. Who are we comparing? Mountain folk with what? Desert folk. So that first group, the first sample we have to take is the mountain folk. The second sample is the desert folk. Mountain. What's this? Desert. Okay, give you guys a few seconds to copy this stuff down and see what you get. Okay, so here we go. We're going to use the what? The modern method and the 5% low significance. So let's read this here. The proportion of who? What's your first group? Mountain folk who believe in UFOs is what? Is different than the proportion of desert folk. Okay. As claimed by who? Snodgrass. So let's write this down. This is going to be what? P1, P2. What does different mean? It's not the same. All right, you guys okay with that? So you're going to write this down. You're going to say P1 is not the same as P2, and then that is the what? The claim, okay? Now, where does this claim go? Is that a null or is that an alternate hypothesis? It's an alternate. How do you know it's alternate? Yeah, it does not have equality. Good job. That's where it goes. On top, you got P1 equals what? P2. Okay, you guys okay with that? Easy peasy, lemon squeezy? What do you think? So far, so good?
I think so.
What do you guys use? 2 proportion z-test. All right, you guys ready to use the modern method? What do we have to do with the modern method? You guys remember? We got to see, is the p-value smaller than the level of significance? Is p less than, what's alpha? 5%. Let's get out. Stat what? Test. Number 6, 2 proportion what? Z-test. You guys are good with that one? Okay, put in your sample information. So for the mountain people, what's the successes? Right? Notice again, they gave it to us this way, without words. And when they do that, I like that. Because who wants to write everything down, right? So let's enter the information, okay? You're going to get what? 118 divided by what? 500. And then you're going to have what? Ooh, I see a typo in my notes. Go back to the notes. This is going to be 2. Okay? $288,700. Now, what kind of test is this? We didn't even mention that. Do you guys know what kind of test this is? How do you find out? You look at what? Right here. If it's not equal, what do you say? To what? That's a two-tailed test. Where does that even go? Well, the not equal. Okay, you guys okay with that? And it's on the not equal. So we're all ready. Hit calculate. Let's see if we can figure out the p-value. Let's read it. What's your p-value? Do you guys know? Oh, I'm glad. This is, let's see if you guys can tell me. What's your p-value? This is 2.42 times 10 to the what? What is this? Anybody remember what this is? You say that's e to the minus 10. What is that? What is e to the minus 10? This is scientific notation. Is that true? This is saying times 10 to the minus 10. So you're going to move that decimal 10 spaces to the what? To the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. Fill in the gap with our zeros. Okay. So you're going to have 9 zeros in front. If we approximate to the nearest thousandths, what is your p-value approximately? Do you guys know? P is approximately what? 0. Okay. If P is approximately 0, what do you guys know? What does this actually mean? Is 0 less than 5%? Say yes. What does that mean, ladies and gentlemen? You know what this means? It means your p-value is what? Is low. If the p-value is low, what do we say? The null has to what? Go. So this is the probability that your null hypothesis is what? Is valid. Probability, your null hypothesis is valid. If it's If it's less than 5%, what have we always been saying about probabilities that low? It's not likely. So what you're really saying is it's not likely, okay? It's not likely that your null hypothesis is valid. Valid. That's why it has to go. The null has to go. And so what do you do automatically? If the null is gone, you accept that alternate. What does that mean about the claim? What are you guys hugging? Are you hugging the claim? Then your sample what? Supports the what? Claim. So what this is saying to you guys, let's really dive deep. P naught is not equal to P2. And more importantly, if I go back to the calculator and I want to look at some details, do you guys know what the sample proportion is for the first sample? Do you guys see that P1 in the TI? That P1 with that hat is your sample proportion. It's 0.236. What is P2? That's 0.411, okay? Now let me express to you guys again. What that means, what you've read, is, let's use the colors, okay? The proportion of mountain people that believe in UFOs is about 23.6%. The proportion of who? Desert people who believe in UFOs, there's your desert, is about 41%. So what do you know about this? What do you guys think? What do you know? What is that suggesting to you? You know, the test is saying they're not the same. That the proportions are not the same. They're different. I would say to you, the desert people are more likely to believe in what? UFOs, based on this sample. So you're looking at a lot of information that makes scientific sense, ladies and gentlemen. So yeah, it looks like the desert people are more likely to believe in what? UFOs. What do you guys think? Isn't that interesting? No? Somewhat? I don't know. Then let's do another interesting question. I'm just going to ask you guys. I asked the other class. I'm just curious. Did you guys have a good lunch today? Yeah. You know, I had a nice salad. My wife packed a salad for me. Oh my God. Really? I should be grateful she put a salad. But I'm not a rabbit. Who eats salads? Rabbits or snakes or anybody? Who eats salads? Do rabbits eat salads? I don't know. I know they eat carrots. Anyway, you say, why am I thinking of lunch? Well, how about if I ask you guys this question? Because I asked the other class, the morning class, I said, because we worked on a hypothesis testing question, and it's, again, probability. What do you guys prefer? I'm wondering, do men and women prefer different things for lunch? Do men and women even eat different things? Do you ever think about that? How about this? Do college students eat different things from lunch than non-college students? Man, I'm going to blow your guys' mind. Maybe. I don't know. What two groups do you guys want to think about? You want to think of men and women, or do you want to think of college students versus non-college students? What do you think? Who should we think of? College students or non-college students? I don't know. Let's ask you college students. What do you prefer for lunch? A sandwich? I mean, I'm with you on that one, by the way. I like that. But some people might prefer. Anybody here prefer pizza? Some people prefer pizza. Anything else? Anybody here prefer a burger for lunch? That's a high school preference. All right. Maybe we should have asked high school students. What do you guys prefer, right? But this is college students, huh?
What about the deli?
I know what the other class preferred. How about if I say this? Anybody here prefer sushi for lunch? There you see it. Now I get everybody's attention. It's kind of funny to me because the last class, they preferred sushi for lunch. Isn't that interesting? Huh? I don't know. It's you guys. What you prefer for lunch?
The deli.
A deli?
The deli.
What do you order?
I usually get myself like a meat. I usually get myself like a meaty sandwich. Very meaty.
What kind of meat?
Pepperoni, salami,
Okay.
ham.
All right.
Maybe mix some beef in there too.
Okay.
Some baby Swiss cheese.
All right. You get that at Subway?
Yeah.
All right.
You even throw in tuna as well. My meats are. I like my sandwiches very meaty.
Okay. Well, that's fine. All right. How about if we create a problem here? Let's do one, okay? The proportion of college students, okay, who prefer sushi for lunch is more than the proportion of non-what? College students. As claimed by who? Good old what? Good old Snodgrass. What do you guys think? Okay, now I'm gonna give you guys again. This is gonna be. I'm gonna give you the information in a way that's less writing for myself because it's been a rough day already. Let's say a sample of the first group is gonna be college students. Sample of 120 revealed that there was 34 successes. Sample 2, 200 college students reveal, I'm sorry, this is non-college, 200 reveal there was 50 successes. I'm going to say use the 1% level of significance to test this claim. All right. Okay, so we'll give you guys some time to write this stuff down. Okay, we're comparing college students versus non-college students. Maybe there's a difference. I don't know. That Snodgrass is making a claim. Proportion of who? College students. That's for your first sample, by the way. College students who prefer sushi for lunch. It's your preference. Is more than what? Proportion of what? Non-college students as what? Claimed by Snodgrass.
Is it 1%?
Yeah, 1%.
Okay.
So, you're going to have either these three. Alpha could be 5%. Remember, a probability less than 5% is not likely. They can even make that threshold lower. They can make it lower than 5%. They can make it a very sensitive test that's even lower. That's 1%. You're like, woo, it's a very sensitive test. But the standard is 5%. They could even make it less sensitive. They could say 10%. Sample 2, non-college students. So this is the group. College versus what? Non-college. Okay, so let's write this stuff down. P1, P2. What does more than mean? Anybody know what's more than? P1 more than P2. How do we describe that? Thank you so much. Greater than. Is that true? So what are we going to write down? P1 is greater than P2, and that, folks, is the what claim? No alternate, no alternate, no alternate. Where do they belong, ladies and gentlemen? No alternate. Where is it?
Alternate.
Thank you. It's an alternate hypothesis. All right. P1 less than or equal to what? P2 is the logical opposite. So if I said to you, what kind of test is this? Right? You always look at the alternate hypothesis. What direction is that pointing? Anybody want to tell me? That's pointing where? Is that inequality pointing in what direction? This is a right what? Tail test. Okay, so ladies and gentlemen, what's the command we use in the TI? To proportion Z what? Test. Stat what? Test to proportion Z test. That's number 6. What's your X1? How many successes? 34. What's the sample size? 120. Are you guys looking at the information here? You guys see what I'm saying? You enter this. You enter this. You guys look at the videos when you get home, or good job. Okay. So now let's enter, ladies and gentlemen, the second sample information. And we say, okay, what is X2? 50. What is N2? 200. What kind of test is this? So make sure your inequality points to the what? To the right. You guys see that there? Is it pointing to the right now? All right. Hit calculate and look for the p-value. What's your p-value? P-value is approximately what? 0.25 what? 6. Okay, 0.256. What do you guys know? Is the p-value low? Well, it's certainly not lower than the level of significance. Okay, because the level of significance is 1%. That's a very sensitive test. So the 25.6% is not lower than the 1%. So what does that mean? We have to keep the what? The null. All right, you must keep the null then. If you keep the null, go find the null and hug it. Keeping the null means you're getting rid of the what? The alternate. What did you get rid of? The claim. What does it mean about your claim? The sample what? Does not support the what? Claim. Okay, you guys okay with that? Should we give you guys one to try on your own? Let's try this. The proportion of what? Let's compare. What groups do you guys want to compare? What are you guys interested in? What are you guys interested in? The proportion of what? Of male college students who prefer. Any of you ladies play video games? Any ladies in the room, you play video games? No? I'll say who play video games. And I'm going to change this one. I'm going to say the proportion of female is less than the proportion of what? Male college students. It's claimed by Snodgrass. use the 5%, and then I'm going to give you sample information. Yeah.
Shouldn't you change it from male to female? Because it says male twice.
This is female, first one.
I didn't see it.
It's okay. So sample size of the female is 500 and 132 successes. Sample size of the others is 800. Use the 5% level of significance to what? Test this claim. Okay, I'm going to give you guys some time to try this out on your own. And let's see what you get. Okay, should we try this out? The proportion of who? Female college students who play video games is what? Less than the proportion of who? Male college students. As claimed by who? Snodgrass. So this is what? P1, P2. What's your inequality? It's less than. Is that true? Okay. P1 less than P2, and this is your what? Your claim. Now, can I ask you guys, where do you place this hypothesis, okay? Right? Where do we place it? Is that a null or an alternate? Where does that go? Where does it go? Good. Because it does not have a condition of equality, right? So What's the logical opposite? P1 is greater than or equal to what? P2. Anybody have any questions on that? Nope. Okay, you guys okay with this? Easy peasy? This is going to be a what? A left tail what? Test. And then you're going to use the what? 5% level of significance. Here's alpha. No. Female. So sample 1 is going to be for the who? Female college students. And then sample 2 is going to be for the who? The male college students. Okay? All right, you guys okay with this? We're going to use the modern method. We're going to have to check is the p-value less than the level of significance. Is that p-value low? What do we mean by low? Smaller than 5%. What's the command in the calculator? What is it? 2 proportion z what? Test. Stat, let's do this. Stat test. You guys okay with that? Stat, what's this? Test. 2 proportion z test. So go with the first sample. What is this? 132. Those are your successes, right? This is sample size is 500. Now, 322 successes for the second sample, and the sample size was 800. What kind of test is this, ladies and gentlemen? So make sure we make this inequalities on the what? On the left tail. This is a left tail test. Okay? Left tail, hit calculate. Calculate. And does anybody want to tell me about that p-value? Is there anything interesting about your p-value? What do you know about that p-value? That p-value is going to be what? Close to what? Close to 0. Isn't that scientific notation? You got that e to the minus what? 7 power? Okay, so what does that mean? Your p-value is approximately 0. Is that low? Is 0 lower than 5%? So the p-value is low. What does that mean? The null has to what? Go. So if your p-value is low, then the null has to go. You say, how low does a p-value have to be? Less than the level of what? Significance. That's the probability that the null hypothesis is valid. It is small. It's close to 0, which means it's impossible. Null has to go. So go to the null and you say what? Goodbye, null. if you just told the null goodbye, what did you just do? You accepted the alternate, and then the alternate happens to be your what? Claim. So what do we say? The sample supports the claim. Good job. So this is a very good what? Example. The sample does what? Supports the what? The claim. Let's give you guys a break. What do you guys think? Should we give you a break? Okay. Did you guys earn your break? No? Let's give you a quick break. Break.